If a gas at 2.3 atm and 6.1 liters becomes 4.5 liters, what will the new pressure be? First, let's write down our information. So we have 2.3 atmospheres for our pressure. So that's going to be our pressure 1. Then right after that, we have 6.1 liters. That's a volume. So that'll be our volume 1. Then after that, we have 4.5 liters. That's a volume. So that'll be our volume 2. Then the question comes, what will be the new pressure? What will be the new pressure? This pressure they're asking for corresponds or correlates to the 4.5 liters. How can I tell that? Well, it is in the wording, but what's most important is 99% of the time, those things that are grouped closest together in the sentence, like the 4.5 liters and the new pressure, are ones that are in the same group, correspond to each other. So I'm going to put our question here, pressure 2 equals question mark. Now, you can figure out or know that this is Boyle's law, but I don't prefer to do these questions that way. All I want to do is solve for it. What I'm going to start out with is that I have one set of pressures and volumes and another set of pressures and volumes. So that means I'm dealing with the ideal gas law somehow. I'll have this group as one ideal gas law, and I'll have this group as another ideal gas law. So my first ideal gas law, I can just write PV equals nRT. And then since these guys are labeled 1, I can just label this 1, 1, 1, 1, 1. My second ideal gas law, PV equals nRT. And since these guys are labeled 2, I can label these guys 2, 2, 2, 2, 2. Now, if I want to figure out my specific formula that I need, all I have to do is cross out the things that I'm not using. So I have a pressure, I'm going to use a pressure. I have a volume, I'm going to use a volume. But there's no moles, so I don't need the moles. There's no R mentioned, so I don't need the R. There's no T mentioned, so I don't need the T. I do the same for the other side. Volume and pressure, so that means I don't have N, I don't have R, I don't have T. After you're done with this, you can bring them together. I'm going to take the P1 and the V1, and I'm just going to equal it to whatever's on the other side. Equals my P2 and my V2. And therefore I've created Boyle's law. Now let's solve. For my P1, I have 2.3 atm. For my V1, I have 6.1 liters. These guys equal my P2, which I don't know, so I'm just going to leave it as P2, multiplied by my V2, which is 4.5 liters. Now, usually at this point, it's the easiest to check the units. You can check the units before, but here it's an easy comparison because you can see both sides of the equation. All that matters is that my units are the same And if you have temperature, your unit should be in Kelvin. So temperature is the most sensitive unit, but the rest of the units are not so sensitive. All that matters is that they are the same. So like here, my liters and my liters are the same. Good, that's what I want. Since my atmospheres is here, that means my answer will be in atmospheres when I solve it. So next step, I'm going to try and get P2 on one side of the equation alone. Therefore, I'm going to divide my 4.5 to get rid of it on this side. And whatever I do to one side, I have to do to the other side. Rules of algebra. So I'll cross this out, and what I'll be left with is 2.3 ATM times 6.1 liters divided by 4.5 liters equals P2. Once again, the liters are going to cross out because of the division, and I'm going to be left with ATM, so that's going to be the units for my answer. If I calculate this, it's 2.3 times 6.1 equals divided by 4.5 equals. So this will turn out to be roughly 3.12 ATM. That's my final answer.